7th grade, Chapter 5, Section 8, Factor Linear Expressions. So starting off with our vocabulary, starting with monomial. Monomial is a number, a variable, or a product of a number and a variable. For instance, the number 2 is a monomial. The variable y is a monomial. The product 3 times x is a monomial. A factor means to write it as a product of its factors. So 6x can be rewritten as 2 times 3 times x. So that's how you would factor it. GCF, the greatest common factor, is the greatest monomial that is a factor of 2 or more numbers. For instance, if we have 6xy and 18x, then our GCF here, well, 6 is the biggest number that goes into both. X is the only letter they have in common, so 6x is the GCF. And in factor form is when a linear expression is expressed as the product of its factors. For instance, if we took 8x plus 4y, we can factor something out. What we have in common with both of these is a 4. So if I take a 4 out front, what do I have left? Well, I'm just dividing everything by 4 here. So I'm left with 2x plus 1y. And if you notice here, if you distribute that 4, you get 8x plus 4y back out, which is exactly what we started with. But sometimes we need to see that factored form. Sometimes we need to take it out to expanded form. So it just depends on what we are doing that day. Okay, so now we are going to subtract using models if needed, but we'll start with getting our like terms together. 5x minus 2x. And then we have 5 minus a negative 4. So 2 negatives make a positive. 5x minus 2x is 3x. 5 plus 4 is 9, so we get 3x plus 9. Okay, so we get negative 3x. Take that negative through, so minus 3x. Minus 4, negative 1 times positive 3 is negative 3, so minus 3. So we get that negative 6x minus 7. Then we have, take that negative through, distribute it. So we get 7x minus 6 minus x plus 3. So 7x minus x is 6x. Negative 6 plus 3 is negative 3. Notice each one of these I've done a little differently. Just figure out which one's best for you. Take that negative 3. So negative 3x plus 3 plus 5x, because a negative times a negative is a positive, plus 3. So negative 3x and 5x gives us 2x. 3 plus 3 is 6. The perimeter of the triangle is 13x minus 1, so P equals 13x minus 1. What is the measure of the missing side? Well, what I know is the total of the perimeter. And I have P on the side. Well, how do you find P? What else do I know about P? I know that if I add up all the sides, I get a total. So if I have x plus 5x plus 2, and I'll call it some other letter. I'll call it y here, equals 13x minus 1. So I'm going to have x plus 5x is 6x plus 2 plus y is equal to 13x minus 1. And I'm going to subtract 2 from both sides. Now I have 6x plus y is equal to 13x minus 3. I'm going to subtract 6x from both sides, and I'll get y is equal to 7x minus 3. So that missing side is 7x minus 3. So our essential question is how can you use numbers and symbols to represent mathematical ideas? Well, today we're going to use them to find the GCF of monomials and to factor linear expressions. Our vocabulary that we talked about are monomials. So remember, those are a letter, or a number, I'm sorry, so negative 2. It's a letter, maybe W, or maybe it's when you have those multiplied together, like 3xy. y. So 3 times x times y. A factor is what makes it up. So say 3 times x times y. Factored form is whenever you take it all the way out. So remember that was that 8x plus 4y. We can take 4 out of both of those and get 2x plus y that we can distribute the 4 back out to. Finding the GCF of a pair of monomials, first you want the prime factorization. So you want to know what all makes up our numbers here. So for instance, 4 and x, I'm going to start with the 4. I want to find those prime numbers that make up 4. For instance, 2. Well, 2 times 2. And then I have the x. So that's why we get 2 times 2 times x. 12x, I'm going to start with that first prime number, 2. It's 2 times 6. Then I can break down the 6 into 2 and 3. So I get 2 times 3 times x, which is how we come up with this one. So what do they have in common? They have 2 2's and an x. So 2 times 2 is 4 times x. So what they have in common is 4x. 48x and 28x, find the GCF. So 48x, I'm going to start with 2, so that's 2 and 24. 2 and 12, 2 and 6, 2 and 3. So I finally came down to all prime numbers. So it's 2, 1, 2, 3, 4. 1, 2, 3, 4, then times 3 times x. And then 28x, 2 times 14, 2 times 7. So those are all prime. So we can do 2 times 7 times x. So we have a 2, and an x. So we have 4x in common. Okay, finding the GCF of a pair of monomials. So again, you go through your 18, 2 times 3 times 3 times 8. You can use a factor tree like I did before. It makes it a little easier, more visual to see it that way, 20AB. So again, what they have in common is they have one number 2, and they have the letter A. So 2 times A is what they have in common. So 16S. So we can do 2 times 8, 2 times 4, 2 times 2 times S. So that's 4 2's times an S. 40ST, 2 times 20, 2 times 10, 2 times 5. So then that's 2 times 2 times 2 times 5 times an S times a T. So we have 1, 2, 3 2's in common, and an S in common. So 2 times 2 times 2 is 2, 4, 8 times S. So 8S is our GCF. Find the GCF of this pair of monomials. So again, find out your factor tree. In this case, we have a 2, a 2, a 3. So 4 times 3 is 12 times C times D, so 12CD. Here we have 14AB, 2 times 7. We have 2 times 7 times A times B, 28AB. So that's 2 times 14, 2 times 7. So that's 2 times 2 times 7 times A times B. So we have a 2 in common, an A in common, a 7 in common, a B in common. So 2 times 7 is 14 times A times B. So we're just multiplying what they have in common to get our GCF. Factor 3x plus 9. So what do they have in common? So this is the one I was talking about earlier. What do they both have in common? Well, you find the GCF of each one. The greatest common number here is 3. You take 3 out. So what are you doing? You're dividing 3 by 3 to get x, and you're dividing 9 by 3 to get 3. So the factored form of 3x plus 9 is 3 parentheses x plus 3. What do they have in common? Well, the factors of, you can do the greatest common factor. That's one thing. 2 times 6, 2 times 3. 48. 2 times 24, 2 times 12, 3 times 4, 2 times 2. We have a 2 in common, a 2 in common, a 3 in common. This has X that did not. That's everything that we have in common. So 2 times 2 is 4, times 3 is 12. So we have a 12. Well, what happens when we divide everything by 12? I'm left with an X plus 48 divided by 12 is 4. So I'm left with 12 parentheses X plus 4. That is the factored form. Again, factor here. What do we have in common? They did their factor tree. It doesn't look like we have anything in common. So this cannot be factored. And so that's what we put, cannot be factored anymore. So 3x plus 11, 3 is 1 times 3. 11 is 1 times 11, so there's nothing to factor. Can't be factored. Cannot be factored. The drawing of the garden at the right is a total area of 15x plus 18 square feet. Find possible dimensions of this garden. So the total area of 15x plus 13. The GCF of 15x and 18 is 3. So write each term as a product of the GCF and 3. So taking out the 3, when you take out 3 from each one of these, you're left with 5x plus 6. So here we have 3 parentheses 5x plus 6. So the possible dimensions are 3 feet by 5x plus 6. Lily's favorite picture has an area of 3x plus 12 square inches. Find the possible dimensions of the picture. So we need to factor it down. What do we have in common? Well, 3 is 1 and 3. 12 is 2 and 6. 2 and 3. So we have a 3 in common here. So I take out the 3. Well, 3x divided by 3 is 1x. 12 divided by 3 leaves me with a 4. So I'm left with 3 parentheses x plus 4. So the dimensions are 3 by x plus 4. How can you use numbers and symbols to represent mathematical ideas? Well, today we learned by factoring linear expressions using algebra tiles, or by using factored expressions to represent real-world situations like a monthly income and the area of a dance floor. So, of course, you can explain how to factor 54x plus 18 using the GCF. You should be able to tell me that you first find what these have in common. You take the greatest common factor out. So maybe you make a tree first, a factor tree. Then you multiply what they have in common. You take that out. You divide each one by that number. And you're left with whatever they have in common times whatever's left.